A very good morning, student friends. In this talk, I'm going to cover the point group and the classification of point group under the topic molecular symmetry and group theory. So today's topic for discussion is point group. So what is point group? So point group is simply defined as uh, it is a collection of all the symmetry elements that can be associated with a molecule. So usually, if you're going to see uh, the uh, the list of elements, so on the basis of the symmetry elements, at the end one can design a shorthand notation. So that shorthand notation is called as the point group. So especially point group is a shorthand notation which reveals the number of symmetry elements, not only number as well as which element symmetry elements associated with a molecule. So in another words, one can say that the point group is simply defined as the collection of symmetry elements associated with a molecule. But during the point group uh, uh, designation, all symmetry element must obey the properties of group. Means in another words one can say that point group must satisfy the properties of group. So properties of group include the four important laws from the mathematics, especially from the group theory. So all symmetry elements of a point group must obey the closure rule, associative law of multiplication, inverse rule, and the identity rule. And this point group is also useful for storing the information uh, regarding the elements as well as the overall shape of the molecule. Then during designation of the point group, let us see water as an example. Uh, so you want to start with the shape of a particular molecule. So you know that the water molecule has inverted V shape. Then once we know the shape of molecule, then you want to list the symmetry element associated with a particular framework. So you know that E is common element. Then C2 is the overall axis of symmetry of water molecule. Then if you're going for the plane of symmetry, the in water molecule there are two vertical planes. So there is no center of inversion. There is no any SN uh, element. So this is the overall list. So all these the symmetry elements are uh, shown with a shorthand notation. That shorthand notation is C2V. So C2V is the point group of the water molecule. Similarly, okay, if you're going for NS3, the shape is trigonal pyramid. Is common element. Then C3 is the axis of symmetry, and you know that C3 generates the three sub elements. These are C31, C3 choice, and E. And there are three vertical planes. There is no any horizontal or diagonal plane, or there is no any center of inversion. There is no SN element. So this is the overall list, and this overall list can be written in the form of this shorthand notation C3V. So C3V is the point group of the NH3 molecule. Similarly, BF3 molecule, planar trigonal geometry. These are the elements. C3 means C3, C3 means C31 and C3 twice. There are three C2 axes. So there is D3 set. It is one horizontal plane, then three vertical planes, and there are two S3 axes of symmetry. And all these are shown with the help of a symmetry symbol, and that is called as D3H. So D3H is the point group of BF3 molecule. Similarly, if you're going for PTCl2 minus, the geometry square planar, and these are the elements associated with a PTCl2 minus the complex, and all these are defined into a single group, and that single group is the D4H. So D4H is the point group of the PTCl2 minus. So here, for writing a point group, you want to start with the overall framework, the structure of molecule, and for a particular structure, you want to list the elements associated with the particular structure or molecule, and then all these elements are shown with a simple shorthand notation. That shorthand notation called as symmetry group, or it's also called as the point group. Okay, so if you're going to see this table, you know that if you are going for H2O2, sorry, H2O, so this is the structure. So these are lone pairs. If you are omitting lone pairs, only inverted V shape, SOCl2 and like this one. So in this, we know that uh, these are the elements E, C2, sigma V and sigma V single prime. Now all this having C2 point group, NS3, PCl3, POCl3. The structure is like this one. The point group is C3V. So this is the these are the elements with associated with NS3. And then if you are going for N2O4 or diborane, so these are the elements. E3C2 means again C2 plus T2C2, center of inversion, and in this there are along with vertical planes there are there is horizontal plane of symmetry. So the point group is D2 and D2H. So BF3, the point group is D3H. Then AB4 having square plane geometry, point group is D4H. If you are going for homodiatomic molecule like H2 or carbon dioxide or acetylene, so the point group is D infinity H. D infinity H. And D infinity includes E infinity C2s. So there is no any fixed angle. So at any angle we are getting the either equivalent or identical orientation. Then center of inversion, infinity vertical planes, and also there is yes, five. This is because of at any angle we are getting the identical or equal orientation. So because of the same, all these molecules have D infinity H point group, or regular tetrahedral molecules like CH4, SiCl4, all these have TD point group, and TD point group includes these symmetry elements, and SF6 or AB6 having octahedral geometry, all these have OH point groups, no doubt. So here, if you are going to see the classification of point groups, the point groups are to be classified into three major categories. If you are going to see, the first is that DN type point group, second is CN type point group, and third is special type point group. So in DN type, there are two subcategories, DND and DNH. So DND, this point group is to be written when DN DN reveals that DN set means CN plus NC2s. If you are going to see AB3 molecule having a planar trigonal geometry, C3 plus 3C2 is the overall axis of symmetry. AB4 having square plane geometry, C4 plus 4C2s. Benzene molecule C6 plus 6C2. So C3 plus 3C2 means D3 set. C4 plus 4C2s, so D4 set. C6 plus 6C2s, D6 set. So here, this point group is to be written when the symmetry element list consists of DN set. Along with DN set, there is presence of at least one diagonal plane of symmetry. Then at that time, one can write the D and D point group. So N is the fold. So D2D, D3D, D5D like that. So this DNH point group, this point group is to be written when the list consists of symmetry element list consists of DN set, along with DN set there is presence of at least one horizontal plane of the symmetry. So DND and DNH, so these two under DN type point group. Then CN type, there are two sub categories in that. One is CNH, another is CNV. CNH point group is to be written when the list consists of only CN set, only CN axis of symmetry, along with that at least one horizontal plane of symmetry. CNV, this point group is to be written when the list consists of CN with at least one vertical plane of symmetry. So this V is small. Then in special type point groups, there are these are the point group symbols. C infinity V, D infinity S, tetrahedral, octahedral, octahedral. So C infinity V point group reveals that there is C infinity, the axis of symmetry, along with that, yeah, infinity vertical planes. So especially heterodiatomic molecule like HX, SCl, HBr, or CO molecule, carbon monoxide, or AgCl. So all such molecules have C infinity V bond group. D infinity H reveals that there is D infinity means C infinity plus infinity C2s. Okay, with presence of the horizontal plane of symmetry. So a molecule like CO2, molecule like homodiatomic molecule like H2, F2Cl2, all these molecules have D infinity H bond group. Then tetrahedral TD bond group is to be written when the molecule have the ideal tetrahedral geometry. OH bond group is to be written when the molecule have the ideal octahedral geometry. So this bond group is to be written if the molecule has the octahedron, the framework. So especially Buckminster fluorine has this I bond group. So we'll see the table. Okay, if you're going to see C and V, in C and V these are the bond groups C2V, C3V. So for example, inverted V shape molecules, these are the elements, and all these elements are shown in this shorthand notation. So C2 is the bond group. Ammonia, these are the list of elements. So these are the elements. So all these are written in a shorthand notation, that is C3V. Then if you are going for trans C2H2Cl2, the EC2I sigma H, these are the elements, and all these are shown with the help of C2H, the bond group. BOH size, these are the elements, are shown with the help of D3H as the bond group. Similarly, if you are under DNH, these are the 2, 3. So D2H, D3H, D4H. So if you are going for ethene molecule or diborane, these two molecules have D2H bond group, and these are the elements present in C2H4 or diborane. If you are going for AB3 molecule having linear triangular geometry or eclipse ethane, all these molecules have the D3H bond group, and these are the elements associated with these molecules. Then AB4 square planar geometry, the bond group is D4H. So this D4 is to be written because of the presence of these elements. So C4 plus 4 C2s, the D4, and at least presence of one horizontal plane of symmetry. Then DND, D2D, and D3D in that allyl molecule. These are the elements present in the allyl molecule, and because of that, the bond group is D2D. For staggered ethane, eclipse ethane having the bond group is D3H. For staggered ethane, these are the elements, and based on that, the bond group is D3D. Similarly, eclipse ferrocene, the bond group is D5H, and staggered ferrocene, the bond group is D5D. So so tetrahedral molecule, already we have in this table we know that if there is tetrahedral bond group, this tetrahedral bond group also consists of the E8 C3s, 3 C2s, 6 S4, and 6 dihedral plane of symmetry. Octahedral, so these are the exhaustively list. And if you're going for the octahedron geometry, in octahedron geometry or IH or I, molecules having 6 C5, 10 C3 axes, 15 C2, 15 planes of symmetry, and a center of symmetry. So in total, such molecule possesses 120 symmetry elements. So one example is an octahedron having 20 equilateral triangular faces, which is found in the B12 skeleton of the B12H21 2 minus AR. Another example is the dodecahedron having 12 regular pentagonal faces, or Buckminster fluorine C60 along also belongs to the I or IH bond group. So these are the few examples. So here, if you are going to see this one, this molecule having C2H bond group. If you are going to xenon, OF4, this have C4V bond group. If you are going for NO2 minus, having C2V, the bond group. Then if you are going for SCN, the bond group is C infinity V. If you are going for ethene molecule D2H, or BF3, D3H. If you are going for this chromium complex, point group is C6V. For this nickel complex, the point group is C5V. If you are going for xenon F4, the point group is D4H. So these are the few examples. So say for staggered ferrocene, the point group is D5D. So CH4 having tetrahedral geometry, TD point group. So this octahedral SF6 having octahedral geometry, OH point group, and this is for the overall dodecahedron having the octahedron, the framework. So this is regarding the point group and the classification of the point group. So with this, I conclude this part. Thank you so much.